Hey students, this is lesson 5-6. In this lesson we're going to learn how to use inequalities involving angles and sides of triangles. Go ahead and do this review and I'll check back with you. All right, we're going to use the comparison property of inequality. If A is equal to B plus C and C is greater than 0, then A is greater than B. Circle the group of values that satisfies the comparison property of inequality. Okay, let's just look at a quick proof of the comparison property. So given that A equals B plus C and C is greater than 0, we want to prove that A will be greater than B. So C is greater than 0 is given. B plus C has to be greater than B plus 0, and that's just adding B to both sides, so that's the addition property of equality. And then B plus C must be greater than B because B plus 0 is equal to B according to the identity property of addition. And we're given that A is equal to B plus C. So by substituting A for B plus C, we get A is greater than B. All right, and a corollary to that deals with triangles. The measure of an exterior angle of a triangle is greater than the measures of each of its remote interior angles. And that's because the two angles add up to the exterior angle. Remember that from the triangle exterior angle theorem. So since those two add up to the exterior angle must be greater than either one of those. So these two will always be less than that one. All right, and here's a proof of that. I'll let you see if you can fill in the reasons there. So I'll just pause here. All right, so let's apply this corollary. Explain why the measure of angle 1 must be greater than the measure of angle 4. And what we're going to do is say, well, we know from that corollary that we just proved that the measure of angle 1 is greater than the measure of angle 3 because the exterior angle is greater than either of these two. So it must be greater than angle 3. And that's by the corollary of the triangle exterior angle theorem. All right, and then we know that the measure of angle 3 is equal to the measure of angle 4, and that's because they're vertical angles. And so we can now say that the measure of angle 1 is greater than the measure of angle 4 by substitution. All right, I'll let you try that. All right, another theorem that we can use here is if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So if xz is greater than xy, then the measure of angle y is greater than the measure of angle z. And you can see that here. As long as this side here is longer than this side here, then this angle right here must be greater than this angle. All right, so go ahead and fill in the answer to number 13 there. So as long as we're just learning about indirect proofs, let's do an indirect proof of this one. And I'll let you see if you can fill in the blanks, but this is an indirect proof of the last theorem. converse of theorem 510. All right, so we're going to use theorem 510 here. Which corner of the triangular flatland forms the largest angle? And from theorem 510, we found out that the largest angle lies opposite the largest side. So if you look at these, the side opposite this longest side right here is angle B. So angle B is the largest. All right, go ahead and see if you get that by doing the got it here. All right, so in this problem we want to order the side lengths of triangle LMN from shortest to longest, and we know that the longest side will lie opposite the largest angle, and so the longest side is LN. We'll label that longest. The shortest side will be opposite this 51-degree angle. The shortest side is LM. And so the last side will be the one in the middle. So we want LM first, so that's either this one or this one. And then we want the longest side to be LN, so that would be this one in order. All right, you try that. All right, another theorem that we have is the triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. This diagram up here kind of illustrates why that has to happen. In order to make a triangle, the side lengths have to be a certain length at least, the amount of the third side. And so we get this theorem, which says that xy plus yz must be greater than xc. Yz plus zx must be greater than xy, the other side. Zx plus xy must be greater than yz, third side. So we can tell if three sides can form a triangle or not by using this inequality theorem. Any two of the numbers have to add up to more than the third number. So we can check, and I'll just label these A, B, and C. And so A plus B must be greater than C. A plus C must be greater than B. And so all three of these things have to happen. B plus C must be greater than A. So if I plug in the values, I get 6 plus 8 greater than 13. That looks like it's true. 6 plus 13 is greater than 8. That looks like it's true. And the last one, 8 plus 13, must be greater than 6. So we have three true statements. So this could form a triangle because of the triangle inequality theorem. So yes. For the second one, we would have 3 plus 9 is greater than 12. And right there we have something that's not true. 12 is not greater than 12. So we're going to say false. We don't need to search anymore. Any two sides added together have to be greater than the third side. So for this triangle right here, we're going to say no, because immediately we get a false statement. The two sides cannot add up to exactly the same length as the other side to form a triangle. Go ahead and do problem 4. Okay, we can also use this to find the range of possible sides. Two sides of a triangle are 7 and 9. What is the range of possible? So let's say that this one's 7, this one's 9, and we'll just call this one x. So according to the triangle inequality theorem, x plus 7 must be greater than 9. Also, x plus 9 must be greater than 7, and 7 plus 9 must be greater than x. Now, if we solve those, we get, for this one, subtracting 7 from both sides, we get x is greater than 2. For here, subtracting 7, we get x is greater than -2. And for this one, we get 16 is greater than x. Now, this one, side lengths of triangles have to be positive numbers, so we're just going to cross that one out and not include it. And then we're left with this and this. So we're just going to write that as a compound inequality. 2 has to be less than x, which is less than 16. So the shortest, all the side lengths must be longer than 2 and shorter than 16. Go ahead and you try that. All right, that's it for the lesson. Sorry it took so long. Go ahead and do the lesson check, and we'll talk about this next time we meet in class.